If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in machine series. So today again we will be solving from question number 161 to question number 165. Okay, then let's try to solve these 5 questions. Now in question number 161, what is asked? A synchronous speed of a 7th space harmonic MMF wave of 3 phase 8 pole 50 Hz induction motion. Okay, so there are 5th harmonic, there are 7th harmonic. For fundamental, if there are 8 pole, so for 5th harmonic there will be 45 into this time, and for 7th harmonic it will be 7 into 8 poles because it is rotating 7 times faster. 7th harmonic is what is meaning of harmonic? If the fundamental take 1 revolution, then 7th harmonic will take 7 revolution. So if it is taking it considering fundamental is saying 8 pole, so for 7th harmonic it will be saying, so for 5th harmonic number of pole will be equal to 8 into 5 poles, and for this one also it will see at 8 into 7, 40 poles, it will see 56 poles. So let us see the orientations, that is what is the gap between 3 phases for this harmonic. That means we are considering the phase sequence. So for 40 poles, if you take 1 revolution 360 from one pole to another pole, that is 180, and one pole to coming back to again that pole is 360 suppose. So for 360 rotation, what will be the total for one complete rotation? It is north to south, then for one complete rotation, that is 360 degree in normal in our mechanical system. So in this much pole system, because there are 40 poles, so your electrical degree will be equal to P by 2 into 360, that is 7200 degree for one revolution. So if there are 3 phases are there, so first one, if they encounter at 0, there are 3 phases, so 3 phase will take total length is 7200. So first one if start from 0, second one will start from, suppose it is 360, so what is one start from 0, one start from 120, one start from 240. This is our normal phase sequence, 3 phase. So because it is total angle is now 7200, one will start from 0, one will start from 2400, one will start from 4800 degree. So can you see which degree it is? If you rotate normal, you bring it to normal degree system now. So 0 is 0. What is 240? 2400 means how much revolution it is, divided by 360 if you do, and 4800 divided by 360 if you do, you will see that it is taking 6 complete revolution plus 240 degree, and it is taking 13 revolution and then 120 degree. So ultimately it is at 1 at 0, second one is 240, third one is 120. So it is the reverse phase sequence we have to maintain normally. We give phase sequence in 0, 120 this one. So this rotation will be in reverse direction for 5th harmonic. So 5th harmonic will rotate in reverse direction. What is 7th harmonic will do? Similarly, you can calculate the number total angle for one revolution. It will be 56 by 2 into 360, which will give you 10080. So first one if starts from 0, second one will start from 3360, 6720. You divide by 360, you will see it is 0. It is 9 revolution plus 120. So if it will come 9 revolution 120, and it will come 18 revolution 240. So 9 revolution 120 means it will take 9 revolution. Finally it will come at 120. It will look like 0, 120 and 240. So it is the original sequence. So it will move in forward direction. Now what they are asking also speed. So obviously it will be in forward direction, either A or C. So what will be the NS? NS will be equal to 120 and F by pole. So what will be pole? Pole is 50. So if you solve it, you will find it is 107.14 RPM in forward direction. So that is your option A. Next, if you come to 162, a 400 volt 15 kilowatt 4 pole 50 Hz star connected induction motor has a full load slip, the output torque of the machine at full load. So at full load 15 kilowatt, what is the meaning of 15 kilowatt? That means it is the output power. So it is the full load. So output power is given. You just need to find torque. So you know torque T into omega is equal to power, that is given 15 kilowatt. So you can directly use this one. What is the speed? For that speed you have to calculate NS first. 120 into 50 by 4, that is 1500, and therefore NR will be equal to slip they have given. So 0.041 minus into 1500, that is 1440. So this is in RPM. You have to convert it into radian per second. So what will be radian per second? It will be 15 into 10 to the power 3, 1440 into 2 pi total radian, but it is in per minute, so per second it will be 60. So if you divide by 60, it will come up So if you solve it, it will get 99.47 Newton meter. That is your option C. Now if you come to 163, on the torque speed curve of induction motor shown in the figure, 4 points of operation is given. Which one of them represents the operation of a slip at greater than 1? So you know this is your starting split, and that is your S is equal to 1. And gradually it is your starting torque graph. It is at S equal to 1, this is at S equal to 0. So if you go this one, you are changing the, you are going with a speed which is more than synchronous speed. So your slip will become negative if you go beyond this point. This is motoring side, this is generating side. Here what will happen? Your rotor speed will be more than synchronous speed. Your slip will become negative. So they are asking for slip more than 1. So obviously for more than 1 it will be in this direction. It is reducing 1 to 0. So if you come to this direction, it will be more than 1. So that's why it is W. That is option A. Now in 164, for an induction motor operating at a slip S, the ratio between gross power output to air gap power. So you know whatever air gap power comes, that into S get lost in rotor. Finally what left? It is 1 minus S into PG. This is your output power. So they are asking you the ratio of the gross power output. This is the output. And this is actually not G, it is air gap, that G, not gross power. Gross power is PO. So they are asking PO by PG. So PO is equal to 1 minus S into PG. So divide by PG. So your answer will be 1 minus S. That is your option B. Now in 165, under no load condition, if the applied voltage to an induction motor is reduced from the rated voltage to half the value, then what will happen? Under no load condition, the applied voltage of induction motor is reduced to rated voltage, half the rated voltage. So if you bring it to half the voltage, then what will happen? Because it is at no load condition, PD is generally changed by the if you change the frequency, and it can also change with the type of voltage, but for that you have to give some load. If it is in loaded condition, then only there will be, if you change your V, then only there will be change in I, because of load I will be there. So if you change I, then torque will change. So accordingly, if torque will change, then speed will automatically adjust to make that power. So but if you change the voltage to half in no load condition, there will be negligible change in speed, and current will decrease, because if you reduce, because no load also it is taking some currents which is covering the no load speed, no load losses. So if you reduce that one, then you can think of your iron loss will also get reduced, because that is directly proportional to V. So if it get reduced, so that means power is reducing, so it will take less current. So that's why option D. If you like the video, then press the like button and please give your valuable comments in the comment section.